So now we're going to find the sum, product, quotient, and difference with just functions themselves. We're not going to evaluate them at anything. So look at these examples. We want to find the intersection of their domains. So the first thing we want to do is actually come up with the domains. So the domain of the first one, remember that you can't have a negative under a square root, so x must be greater than or equal to 0. For g, the domain will be all real numbers. And for h, the domain is all real numbers. So f plus g means to find the intersection of this domain and this domain. Intersection is what they have in common. So the domain is going to be 0 to infinity. That's what they have in common. So look at g divided by f. If you want to find those intersections, it is 0 to infinity. However, you're dividing by f. So can you have a 0 in the denominator? You can't, right? So that one would still be 0 to infinity, but you would not include this 0. So let's go ahead and evaluate these and see what we get. F plus g. Well, here's f and here's g. None of these are like terms, so that's pretty much your answer. Just like that. The same thing is true for f divided by g, g divided by f. You would have your 3x plus 1 divided by your square root of x. Now remember, you're not supposed to have a radical in the denominator, so to rationalize it, you can multiply by the square root of x, and you end up with the square root of x times 3x plus 1 all over the square root of x squared. But that gives you the square root of x times 3x plus 1 all over x. So this would be the quotient, g divided by f. We do need to make a note that these are the domains of those functions. Okay, so how about g times h? G times h, the domain would be the intersection of g and h. The domains of g and h. So if you find the intersection of these two domains, you actually get all real numbers. And the same thing is true for the domain of number 4. So now we just need to find the product and the difference. G times h, we're going to have 3x plus 1, that's g, times h, which is x minus 1. Just multiply it out. You get 3x squared minus 3x plus x minus 1. 3x squared minus 2x minus 1. So this is the product of g and h, and this is the domain of g times h. So now we want to find the difference of g and h. So we're going to have our 3x plus 1, and we're going to subtract our x minus 1. If you notice, every time I write down these functions, I use parentheses. Unless, of course, it was division, because we don't really need them there. We definitely need them on subtraction, because you have to distribute this negative 1. So you get 3x plus 1 minus x plus 1. Combine your like terms. 3x minus x is 2x, and 1 plus 1 is 2. Here's a couple for you to try. That's all there is to it. Now we're going to talk about composition of functions. This notation means f of g of x. The second one means g of f of x. G of f of x and f of g of x. You can also write it this way. Sometimes the second way makes a little bit more sense. At least it does to me. It kind of tells you exactly what to do. If you notice, g is inside f in the first one, and in the second one, f is inside g. And that's exactly what you want to do. You want to take a function and put it inside another function. So let's see how to work one of these problems. This first one means f of g. I like to write it this way. F of g of x. Well, this means find all of the g of x's, and once you get them, you put them into f. So look at the domain of g. The domain of g is 1, 2, 3. I looked at that one because g of x is on the inside. Whatever's on the inside, that's the domain we're looking for. So we want to find g of 1, g of 2, and g of 3. Once we find those, we want to put them inside f. Okay, so what is g of 1? G of 1 is 4. But then it says to find f of 4. F of 4 is 9. So for this particular problem, we put in a 1 and we got out a 9. So whenever you're writing out your function, f of g, you put in a 1, you get out a 9. So then what is g of 2? G of 2 is 5. And what is f of 5? F of 5 is 10. So this time you put in a 2 and you got out a 10. So we would have another ordered pair, 2, 10. Okay, so we do the last one. What is g of 3? G of 3 is 6. But what is f of 6? There is no 6, right? Well, that means this doesn't exist. So this is the function f of g. So the domain of this particular function is going to be just 1 and 2. So how do we determine what the domain is before we even get started? It works like this. The output of g has to be in the input of f, right? So if you notice, we have a 4 here as an output, a 4 here as an input. We have a 5 as an output, we have a 5 as an input. Whatever those are, you look at the x values in g. I know that's a little bit crazy. Look at the x values in g because we're talking about domain, right? That would be your domain. A little bit different than finding the domain of those other functions. This time you actually are doing a composition. So the output of the inside function must be in the input of the outside function. If it is, then the domain is the input of the inside function. Ooh, you may have to rewind that and listen to it again. That was pretty crazy. So let's say it again. To get the domain, the output of the inside function must be in the input of the outside function. And if it is, then the domain is the input of the inside function. Wow. Let's try another one. Let's see if we can get that domain right off the bat. So we have to find where the output We're wanting to find j of h, by the way. So we're looking at the output of the inside function. That's going to be 0, 0, 8. We need to know where this output is in the input of j. So what y is in the x of j? Well, the x of j is 0 and 6. The only place those match will be 0. Right? Wherever those match, you look back at the x values that correspond to those y values. So it looks like we're going to have a domain of just 2 and 4. That's what it looks like to me. If you're not really sure, go ahead and find the domain of the inside function. The domain of this one is 2, 4, 6. Okay? So we want to find j of h of 2, j of h of 4, and j of h of 6. Now, if you know that the domain is just 2 and 4, you wouldn't even do this last line. This is just if you didn't know that. So what is h of 2? H of 2 is 0. And what is j of 0? 7. So for this, if you're finding j of h, you put in a 2, and you got out a 7. Then you find h of 4. H of 4 is 0. And j of 0 is 7. So you put in a 4, you get out a 7. If you already knew that's all that's in your domain, you just stop there. But if you didn't know, keep going. What is h of 6? H of 6 is 8. And what is j of 8? There is no 8 here, so this doesn't exist. So that's another way you can just double check yourself and make sure that you have the correct domain.